Hi everyone. Why the cuts in the capacitor plates? In this video, I'll explain exactly why those cuts are there, and I'll also give you examples in circuit. Welcome to a brand new Tech Tip series here at Mr. Carlson's lab. If you'd like to stay current in this Tech Tip series, definitely subscribe and stay tuned. I'll have many more Tech Tips videos coming in the future as well. All right, let's get started. Multi-section tuning capacitors like this are found in all sorts of different equipment. They're found in AM/FM radios, so stereos. They're found in test equipment. They're found in transceivers. They're found in variable frequency oscillators, or VFOs. They're also found in beat frequency oscillators, or BFOs. This one is really large, and the reason that I'm using something that's so incredibly large is because it's easy to point to and, of course, easier to get the point across. But you'll find these miniaturized in, AM/FM radios and things like that, but, they all pretty much do the same thing. All right, again, just, different capacitance ratings and, all that kind of thing. So this one here is known as a 4-section ganged, so they're all attached together, tuning capacitor. So whenever you hear a ganged tuning capacitor, that usually means that one or more sections are attached together with one particular shaft. If you're looking at an alignment procedure in anything and it says fully mesh the capacitor, that means that is fully meshed. If they say fully open the capacitor, that's fully open, and of course this would be half meshed. All right, so when a capacitor like this is fully meshed, it's at maximum capacitance. All right, so this would be at the lowest frequency. When the capacitor is open like this, it's at minimum capacitance, and it would be at the highest frequency. So if you're tuning, that will be a great help. Now, the purpose of this video is to explain these little cuts in the capacitor plates. They're not just there for looks, they're there to help you align the dial tracking of whatever you're working on. You got to remember, in a radio receiver, when you're tuning the dial, you're actually tuning an oscillator inside the radio receiver and consequently other sections depending on how complex the radio receiver is, but one section will be tuning the oscillator. In order for the dial, so when you're tuning this, there's a needle that's moving back and forth on the dial, right? So say you have a needle here and you're moving this around and this is attached to a string and it's moving back and forth. In order for the oscillator in the radio receiver to track with the dial, they have to be aligned correctly. And sometimes it's very hard to make the actual dial of the radio receiver read what the actual radio is receiving, because again, they're two separate analog units and they both have to track with one another. And that's what these little cuts allow you to do. They allow the capacitance to come in slower at different portions, or even a little faster at different portions. So if I move this here, you can see this little plate here. So if I bend that plate out like so, and I bend, say, this plate out on the top, I'm doing this on camera here. I bend this little plate out, bend this one out here, like so. You can see at that point that when these plates come into these plates here, of course, the capacitance is going to be moving pretty quickly, and then all of a sudden, as it gets to this plate here, it's going to start slowing down. It's not going to come in so quickly anymore. And as you can see, it's going to come in a lot slower up here as well, and then it'll come in a little quicker, and then quicker as we get to the end here again. You'll also notice that when they design these capacitors, they're not fully half round. You can kind of see how it has a little bit of a flat spot here and a flat spot here. And they've done that for the particular application that this capacitor was supposed to be in. That makes it track correctly with whatever they had intended this capacitor to do. So what I'll do is I'll get an actual radio receiver out here and I'll demonstrate the action of moving these little movable or bendable plates on the capacitor here. Here's a really neat old radio receiver from way back when that will receive a restoration on this channel in the very near future. So if you like to see restorations, another reason to subscribe and hang around. So I'll take this older radio receiver and make it perform the way it did when it rolled off the factory line. This is a Delco radio receiver, back when Delco made radios for homes. Isn't that neat? So this capacitor here, you can see the adjustments. You see the little cuts in the plates down there. I'll zoom on in. And you can see the little one next to it doesn't have any cuts, and that's normal as well. When the capacitor gets really small like this, so you can see the little half-cut plates are really, really small, they don't put the cuts in them, so this allows me to demonstrate actually on a side that doesn't have any cuts. This side here will adjust the maximum sensitivity of the radio receiver. So this tunes the antenna in the back here. So in this radio receiver, this in the back is the antenna, this what you see back here, and this tunes this to maximum sensitivity no matter where you are on the dial. So it's always peaking up the maximum sensitivity. That's what this side does. Now in this application, it's harder to demonstrate the actual differences because of course I would have to have a whole lot of test gear attached up to show you the peaking, but this is going to need adjustment as well. What I'll do is I'll show you with the oscillator, and this also allows me to demonstrate on a capacitor that actually doesn't have the cuts. So this is really, really good. This actually turned out very well. So now I've got a signal generator attached to this, and if we look at the dial here, this is an analog dial, right? You got to remember the oscillator in the radio here and this dial don't know where each other are, so they have to be tuned to exactly the same area. Now if I move this down, I have this tuned to a signal generator running into this at 1000 AM. Now you see how the needle is not on that little mark there. It tracks at both ends, but it's not on right in the center. You see, that's where it should be right on frequency. That's called dial tracking. See, that's where it should be making the maximum amount of noise, and then it should go off frequency on either side. So in order to adjust the dial tracking on this, it's a really simple procedure. If it tracks at both ends and it's off in the center and all the adjustments have been made, all that one would do is, I'll just get this in the capacitor plates here, and I'll move, I don't know if you can actually see this, maybe this side you can. So I'll move that one apart like so. See how easily that moves? And I'll move this one apart on this side, just like that. All right, now let's see what happens with the dial tracking. And it can be adjusted still if it's not on. So now remember, we want it to be at maximum signal right on that mark. Okay, so here we go. See, we completely fixed that. So now the dial will track correctly. And the cuts do the exact same thing. Some oscillators will have capacitor like this with cuts in it at the actual oscillator end. This one again is so small that they actually didn't put the cuts there. So by bending the two outer plates out, we now got the dial to track correctly. Now to have this radio peaked at, so just say at this point here, it could be more sensitive. It could be more sensitive, we would adjust those plates with a signal being injected into the antenna, and we would adjust those for a peak as well. And we could make everything track perfectly, and we could make a very, very sensitive AM radio receiver. In fact, these older AM radio receivers with vacuum tubes in them like this are extremely sensitive. This is known, this particular one is known as an AA6 or All-American 6 style radio receiver. So very sensitive, and the AA6s were designed for fringe areas way back when. So if radio stations were very, very far away, the AA6 had one extra stage of amplification, making this radio receiver extremely sensitive. I will add that moving these little cuts in the plates over here, in and out, like so, is exactly the same thing I did on this side here. It's just this capacitor is much larger, so they've put basically reliefs in the plates in order to help you bend them a little bit better. That's the only difference between the cuts here and no cuts in this particular plate. Again, the capacitor is so small on this side that they didn't need to put the little relief cuts in it. So bending these out is identical to what I did in the oscillator section right here. If you enjoyed this video, definitely subscribe and stay tuned. I'll have many more videos just like this coming in the very near future. I'll have tips regarding modern electronics and tips regarding antique electronics alike. So whether you like vacuum tube circuits or solid state stuff with transistors and ICs, it's all here. I'm pretty versatile that way. If you'd like to take your electronics knowledge to the next level and learn electronics in a very different and a very effective way, and gain access to many of my personal electronic inventions, creations, and designs, you're definitely going to want to check out my electronics course on Patreon. There's many projects there for you to build. There's over 230 videos at this point on Patreon, and it's growing all the time. Those videos have attachments with all sorts of projects, both modern and antique. You can choose what you like to build and learn. It's a great place to be. Definitely check it out. I'll put the link just below the video's description under the Show More tab, and I'll pin the link at the top of the comment section. So click on that link, it'll take you right there. All right, until next time, take care. Bye for now.